Hello friends, so in this tutorial we'll be simulating a quarter car model. So this is the mathematical modeling of quarter car model. I've taken this reference from Fundamentals of Vehicle Dynamics by Thomas Gillespie. So he illustrates the model of a quarter car model in two equations. We'll be solving these two equations in Simulink and be plotting the graph and find the nature of the graph, how it appears. So this basically considers two major topics in it: sprung mass and unsprung mass. So in a ground vehicle with a suspension, the unsprung mass is the mass of the suspension, wheels and other components directly connected to them rather than supported by the suspension. So, and sprung mass in a vehicle is the opposite of the unsprung mass, which is it is mass of the vehicle in which the suspension is the portion of the vehicle's total mass is supported by the suspension. So in case of unsprung mass, it is not directly connected to them, whereas in case of sprung mass, it is directly supported by the suspension. So, and you can find out the different the names given to the constants here. So what this z double dot means is that it is the acceleration. So if we integrate the acceleration, we will get velocity, and if we further integrate the velocity, we will get displacement. So z double dot is acceleration, z dot is the velocity, and z is the displacement. And if they have written the same thing over here, and the remaining constants are also mentioned here. So we'll be using these two equations to in the Simulink and generate the graph. So this is the MATLAB workbench. Looks like. So we'll open the Simulink workbench first, and we'll start with a blank model. So it appears here. So let's open the library where we can find all types of blocks available. So for this particular exercise, I'll be using a certain set of blocks. So first I'll drag all those and put it into this window. So I'll be needing a scope to display the final output. So I'll click and drag it over here. And the firstmost thing which I require is a step function. This I can find it in source, and we have it here. So step, let's just drag and keep it aside. Then we require an integrator. So it can be found in commonly used block. This is the integrator we require, and an add function as well. So you can find it in math operations. We require gain as well, so we'll put it aside. And sum, yes, this one. We also require sum, and we need an add function. Add. So here it is, just drag it, add, and that's it. We need these set, and I'll be building the same by these 6 blocks. I'll minimize this and like this. Yes, so it's the step. Then we have add, scope, and integrator, sum, and the gain. So we'll begin building the circuit diagram. So we'll start by this add function. So by double clicking on this add, we can add any number of signs, positive as well as negative. So I'll be using 3 positive signs because I'll show it over here. Because here we can find out there are 3 terms on the RH side. So we'll be shifting all these terms which are there on the LH to RH side and except M. So first we'll take these 3 positives. That is the reason why I have taken 3 positive. You can just make this look bigger by dragging this like this way, so it looks neat and you can easily get to know the signs inside it. So to fit the screen, you can press space bar as well, and to zoom in and zoom out you can use the scroll of the mouse. So we have 3 positives now, and the first gain here, and let's connect it from here to here. So this gain, if we double click it, you can put the value of it and put 1 divided by 45. 45 is the constant. I have taken 1. Why divide? Because of this reason, mz. If we need m will is equal to 1 divided by z double dot. So it is nothing but m inversely proportional to z double dot. That is the reason why it comes under 1 divided by z. So we have our first gain, and now we'll be using the integrator. So this is the z double dot. So I'll just connect it from here to here. Z double dot. We will need another 2 integrator because we have to integrate 2 times. That is we need to integrate acceleration to get velocity. We need to integrate velocity again to get the displacement z. So we need 2 more. We can get it directly from here by pressing the control button and dragging it from here, rather than again going to the library window and importing it from here. So this actually saves some time. So we have 3 integrators. So I'll just connect these integrators with each other. So these integrators are connected, and the scope I'll be connecting it at the end. It is used to display the result. And let's connect this step function to the first point. So double click, we'll be using this final value, and step time you can put it anyhow. I'll be putting the final value as 450. Press enter. And next I'll be requiring another gain value now. So you can press control and drag it over here, and just keep this one aside. So I need this one in reverse condition so that we can, so to get that, press control and R one more time. So it got reversed. So this is it. And now let's just use this step function, so this add function, connect it from here. So in this also we can change it. So I'll be requiring plus and minus. I'll be explaining why these in later stages. So this again I need it in reverse condition. So control R, R. Just I'll change the signs, minus plus. Okay. So why here minus, it is because I'll be connecting from here to here. It is coming back. That is the reason why it is negative over here, and this to this connected. So I'll just connect this scope as well to this one. So far I'll just go through this circuit diagram once again. So this is nothing but the step function, and I'll be adding, this is the add function, used 3 positive signs because of the LH terms present in the equation, and this is the gain. It is 1 by the value I've put it as 1 divided by 45, and this is the acceleration, and by doing the integration we'll get velocity, and further integrating we'll get the displacement, and this is the scope to display the value or graph, plot the graph or result, you can say. So this is the add function again, minus plus, this is the gain. So I'll be explaining all these terms gains once I complete circuit diagram. So now I require another gain in the same position, so I'll just press Ctrl and drag it and keep it here. And I need another add function or sum function, sorry, and keep it over here. And now I'll just connect it from this point. So this is actually from, I'll just delete it. It's actually from here to here, and this one from here to here. I'll just move this one now. By deleting this first bar, you can see the sign got changed, moved upwards, so we can connect it directly from this one to this. You can just drop it down. This is just to look neat. I'll be just changing certain things, so we are neat now. So this one is over here. And actually I have taken one integrator more, because this is the acceleration and this is displacement, this is velocity, and finally it is displacement. So I will not be requiring this one, so I just correct it once again. So now we have the correct sequence. So and now this one comes to this, just move this. So we have connected this one, and finally we'll connect this to this gain, and the signs are correct, minus positive. So I require another gain in this same position. I'll just drag it and keep it below this one, and I need another integrator over here. So I need the complete set from this one. So instead of dragging each individual components at one time, I'll be dragging this complete set at a time. So why? I'll just delete this one. So why we need the complete set? Because here also we have the same RHS equations or the terms on the right hand side, the second equation as well. So we'll just select this one, and so I'll be dragging like this way and delete these lines. These are not required. we got the complete set now again, and just rewrite it once again. So this I'll delete it for time being. These values we have now. So I need another gain, the final gain here, and connect this one to this. And from here to here, this one got connected, and I need another add function for the second equation as well. So I need to change the signs as well to minus minus plus. So I got 4. Just make it bigger to look clear. And now just do the remaining connections as well. This connected to here, and this is actually, let's try this one. So this is actually not done, so it is connected from here to here and here to here. So it's done. And this is connected here and here. So we have this one, and let's connect this one to here. And first negative sign gets connected over here. So and this one too, like this way, gets connected. This one, and similarly we'll connect this one to this one, and connection, and finally we'll connect this one over here to like this way. And we need another step function as well for the second equation. So just connect it here. So I'll put this value as 150. So I'll just go through the circuit diagram once again, so there are nothing is missing. So just connect it here, right here, and so these all got connected. So I think it's looking good and everything is looking correct. The circuit diagram is correct. Let's just put the values inside it. So this is nothing but 1 by 45. I have already explained it. It is the acceleration. So y divided by, because m is equal to 1 by z. That is the reason why it is divided by. So this is nothing but velocity and displacement, and this is the scope to display the result. And we have this gain. This is nothing but the spring rate front. So we have this value of the constant as 4600 Newton per meter. I'll just put it this way. And this gain is the damping coefficient, the front side. We have this value as well. It is a constant 0.39. So I have this one, and we have this one as 1 by 15. It's the same. It's for the second equation as well. While you have second equation, and we have this last gain. It is nothing but the wheel rate at the front side. So its value is 27340. I put all the constant values inside it, and all the blocks are connected and no block is free. So let's see once again if there are any blocks that are need to be connected. So let's fit it to the screen and run this. So it'll perform a run. So run is complete, and let us check the output of it by double clicking in this scope. So here is the desired output of the quarter car model. So this is what we were looking at. So within 1 second it's getting these curves in 1 second. So we got our design output. So this was about the simulating quarter car model. Thank you.